Hello everyone, in this video we are going to see how the machine language algorithm works. Before that, let us see what is artificial intelligence and where the machine learning comes under that. Artificial intelligence is a subset of computer science with its origins from mathematics, logic, philosophy and cognitive science. And how it is possible nowadays is because of the explosion of data as well as the falling cost of computing power. That means we have now volume of data available. Data comes volume in seconds, and the power of computers also is very high, which is helps to process the data in an efficient manner. So what is the slide takeaway is machine learning is an application of AI. Data science is a broader field that uses ML, AI, and other techniques to extract insights from data. So, volume of data is there from the data. Data science helps to extract information from the data and which uses the ML and AI. Okay, and let us see the next slide. The comparison between the traditional programming and machine learning. So traditional programming, what we usually do in C, C++ or other languages in Python or Java, we write the program and then we compile it, we give the input and the computer does the compilation based upon the program you have given and the output is expected will come. That is the traditional programming. But how this machine learning now varies is we have many inputs, we know what is the output, what should be the output we know. So we give the input as well as the output and the computation is done on million of data and that creates some patterns. That is the program over here. So this is the scenario how traditional programming has changed into machine learning concept. And to learn, the machine to learn, it needs data. So let us know what is data. It's a raw material from which the machine language system learns. And it can be broadly into two categories, structured data and unstructured data. Highly organized data that follows a predefined model, like a patient biomarker data in an electronic health record or reading from a smartwatch. They have some structure, that means they have some proper format to follow. But what is unstructured data is data without the predefined model, which represents the vast majority of information. Like today, like we send emails, we maybe make post in the Instagram, on social medias, WhatsApp, wherever, and the handwritten notes of a physician in the health record. So they all are unstructured data. That means they cannot be organized into a proper format. That is the unstructured data. So from these two data, how the information is got. So this is the example of a data. We say 150/80 is the blood pressure reading, and then the information is it is whose blood pressure and what date. Okay, that is the proper information. Likewise, an example, data on an employee application. So here it is on the employee application record. When he tries for a job, he must have given an record. That is the employee application record. That is a context. Okay, and then another example is number of heart attacks in June. So June, many will have heart attack, and what is the hospital, what is the rate at which the heart attack occurs, that is the information. Okay, this is how the data is converted into information based upon the context. And why we talk about this here is we have data and the data is processed to extract information, and that is done by the machine language techniques. So these are all the steps how the machine learning does its process. Specify the problem. Here define the goal, inputs, outputs and the success matrices. So what is the goal we are going to achieve, what kind of input we give, and what is the output expected, and what is the success metrics, means how successful this algorithm is, or how successful it gave the, how approximate it gave the answer. There are all the success metrics. Okay. Then once we have the data, I have to prepare the data. How to prepare the data? Collect the data, clean the data, and format the raw data into a usable data set. This is often the most time consuming step because if the data is in a perfect pattern, then everything will go smooth. So once the data is collected, because volume of data are there, different form of data are there, all data should be prepared in a neat format. That is done by, that is the time consuming process, which is a very efficient or very important process. Okay. So once the data is prepared, we have to choose the learning method. So what learning method chooses this particular data? Okay, based on the problem, based on data availability, what is the best algorithm? You have to choose the learning method. And once you know the method, apply the method, and using that method, train the model on the portion of the data. Suppose we have some 10,000 of data, we only train on some 5,000 of data, then we try to get the result, refine it, then we give more data, then we expect more results. That means more accurate results. This is how the training will be happening. Okay. And then once you train the data, we get some results. So assess the method. Test the model on the unseen data to evaluate the performance. Okay. So how the data behaved, how the model behaved on the data, and you have to evaluate the performance, how good it is. It is so good, or it is good, or it is better, or it is not good, it is bad. So those performance has to be evaluated. Then we have to again tune the algorithm and refine the data to improve the results. So change algorithm has to be tuned means some factors can be added, or some factors can be removed, or something will be done on the algorithm part, and data is also refined more and more to improve the results. Okay. And then finally report the results, communicate the results and finding to the stakeholders are the customers. Okay. So this is how the machine learning algorithm works. Okay. This is the workflow. And let us see the types of machine language algorithm. We have three types: unsupervised learning, supervised learning, and reinforcement learning. And what is supervised learning is learning with the teacher. For example, the algorithm is given labeled data and the correct answers to learn from. An example given is a student writing with the answer key. Okay, so he knows the answer, so he had to prepare the answer accordingly. He had to prepare the answer. Okay, and unsupervised learning is finding patterns on its own. Algorithm is given unlabeled data and must discover the hidden structure. For example, a detective solving a mystery with only the raw clues. It is again and it is finding pattern means this has happened again and again. Okay. And the third type is learning is reinforcement. It is learning by errors, learning through trial and error. An agent learns by receiving rewards or penalties. Reward means for good answer, penalty means for wrong answer, and then their actions are again they are it learns by the action again and again. By receiving reward means the answer is correct. Repeat the again with good information, good amount of information, and so on. If it is wrong means give negative markings, and then we have to correct the learning process. That way the learning process goes. That is the reinforcement, learning by trial and error. An example is training a pet with the treats. So if we have pet at home, we give something to the pet to make it happy, and the pet will again respond. Then we give the pet some other type of incent, like means other type of some motivation. Likewise, we are training. If it is doing something wrong, we how we train a baby the same way. If the baby is doing something wrong, we just uh, advise them or warn them. If the baby is doing good, we encourage them with the clap. So that is the way the process goes. That is the reinforcement learning. Okay. And these are the three philosophies of the machine learning algorithms. And let us see the models here. In supervised learning, the algorithm is trained on a data set with the right answers already known. The goal is to learn a mapping function that can be predicted from the output for the new unseen data. So the scenario is like this. We have input raw data, mixture of data collected on the way, and then the supervised learning, that means it's labeled learning. We have the training data set, we have the desired output, and the algorithm works on this. And algorithm works on the training data set and what expected output is there, and accordingly it gives the output. Now it is collected the things into different categories. This is one type. Okay. So this blue, blacks, and this mustard colors are ash are removed separately. This is one type of classification. Okay, so two primary tasks for supervised learning: classification and regression. What is classification is it's a discrete category. Yes or no, high, medium, or low risk. That is an example for a patient hospital readmission. If the patient is in the high risk, again we have to readmit the patient for treatment. If it is the patient is in the low risk, we can leave them and we can have some follow-up care at home itself. So that is the classification based upon the discrete category. What is regression is predicting a continuous value, like the patient is examined for the blood pressure or the heartbeat or whatever, some continuous values, and by this they expect what is maybe the tomorrow's result. If today this is the case of the patient condition, what will be tomorrow's condition? Some guessing. That is called regression. Okay. So these comes under the supervised learning. And next is about the unsupervised learning. Here what we do is we work with the data that has no pre-existing labels. The goal is not to predict a known outcome but to model the underlying structure or distribution in the data to learn more about it. Okay. So there is no expected output here, but we have to find out the underlying structure, some patterns. Okay, so this is the input data, a mixture algorithm is given. There is no supervisor here, there is no any expected input or output is there, but just a algorithm which makes some collections. Here clusters means some groups. Here we can see blacks are one cluster, ashes are one cluster, and this mustard color is one cluster. Here there is a mixture of two different shapes that we can cluster it by next level of refined algorithm. Okay, so the two primary tasks of unsupervised learning: clustering. What it does is grouping data points so that items in the same group are more similar to each other than to those in other groups. This is the example here. Is black, it's totally shape is different, color is different, but here even though the shapes are different but the color is same, it is given as a cluster. Okay, so example given in the medical record is segmenting patient into different groups based upon the health behaviors and biomarker data. How the health condition, based on that they can segment the patient groups. Okay, there's clusters. And then what is association is another type of unsupervised learning. What is association is discovering rules that describe the large portions of data, because when there are expected large portions of data, that means the common data, there we define some rules. That is the association. Example is finding that patients who are prescribed drug A are also frequently prescribed drug B. That means it's possible to give the drug B also for the patient who was already given the drug A. That is one common findings. Okay, that this is how the unsupervised learning works. Okay. So as a conclusion, they say once a problem is framed as a learning task, either it is classification, regression, or clustering, the next step is choose the right algorithm. There are hundreds of algorithms, each with its own strengths and weaknesses. The no free lunch theorem is a machine learning states. In machine learning states that no single algorithm works best for every problem. Based upon the problem size, based upon the problem type, based upon the problem situation, and based upon the size of data, if based on all the things, the process, the working of algorithm may vary. That's what they said, no free lunch. And the takeaway from this slide is the selection depends on the size and nature of the data, the specific goals of the project, and the computational resources available. The art of machine learning lies in selecting the right tool for the job. Okay, so the three types of machine learning algorithms here, that is supervised and unsupervised. Under classification, classification and regression comes under supervised, and clustering comes under unsupervised. And under the classification, we have decision trees, k nearest neighbors, and support vector machines. They are common used algorithms, and we'll see in detail about this decision trees in the next video. And under regression, we have two types of regression: linear regression and logistic regression. And in the case of unsupervised learning, there are two commonly used algorithms: k-means and hierarchical clustering. Okay, so that's all for this slide regarding how the machine learning algorithm works. And thanks for watching.